So that brings me to the seventh question. A function f maps the set of natural numbers to whole numbers such that f of xy is f of x into f of y plus fx plus fy. This particular condition, f of xy is fx into fy plus fx plus fy for all x and y, and f of p is 1 for every prime number p. Then the value of f of 1,60,000 is, okay, 1640 is. So let's look at the first approach of solving this question, guys. We want to find f of 160000. Let's split this as 16 into 10 raised to 4. Now, 16 is also 2 raised to 4, and 10 raised to 4 can be further factorized as 2 raised to 4 into 5 raised to 4, right? So technically, this entire number can be written as 2 raised to 8 into 5 raised to 4. So now what we will do is we'll branch it out. We'll write 2 raised to 8 simply as 2 raised to 4 into 2 raised to 4. 2 raised to 4 will further branch as 2 raised to 2 into 2 raised to 2. And 2 raised to 2 will further branch as 2 raised to 1 and 2 raised to 1. Okay. And something similar we'll do for 5 also. 5 raised to 4 can be broken down to 5 square into 5 square. And 5 square can be written as 5 into 5. Okay. Now, as per the given condition, f of xy is fx into fy plus fx plus fy. And f of p is 1 for every prime number p. So, f of 2 should be equal to 1. And so also f of 5 should be equal to 1. So now, if I want to find out, let's say f of 25, f of 25 will be f of 5 into 5, which will be as per the definition f of 5 into f of 5 plus f of 5 plus f of 5, right? We have seen f of 5 is 1. So this entire thing becomes 1 into 1 plus 1 plus 1. 1 plus 1 plus 1 is basically 3. So f of 25 is nothing but 3 in this case. And now by the same logic, we can also find out f of 5 raised to 4, which can be further split as f of 5 square into 5 square. This is like f of x into y, right? So f of 5 square into f of 5 square plus f of 5 square plus f of 5 square, right? F of 5 square we know is 3 into this is also 3 plus this is 3 and this is 3. We have 3 3s are 9 plus 3 plus 3 is 9 plus 6, 15. So f of 5 raised to 4 we have simply found as 15 in this case, right? Now same logic we can apply for 2 raised to 8 also, guys. 2 raised to 1 and 2 raised to 1 both will basically be f of 2 is equal to 1 and f of 2 is equal to 1. Using this, we can calculate f of 2 square. The same logic that we have used for f of 5 square. It is nothing but f of 2 into f of 2 plus f of 2 plus f of 2. We already know f of 2 is also 1. So 1 into 1 plus 1 is also 3. So f of 2 square is worth 3. And here also we have f of 2 square is 3. Now understand, guys, f of 2 raised to 4 will be found exactly the same way that we have found f of 5 raised to 4, right? It will be 3 into 3 plus 3 plus 3. Sum of these two, adding their product. So 3 into 3 plus 3 plus 3 will give me 3 3s are 9 plus 3 plus 3. Same procedure will give me 15. And same way, this is also 15. And 2 raised to 8 can be found by the same logic, guys. 2 raised to 4 into 2 raised to 4 plus 2 raised to 4 plus 2 raised to 4. So 15 into 15 plus 15 plus 15. This is 225 plus 30, 255. That's all. We're just one step in getting our answer. The number here is f of 2 raised to 8 into 5 raised to 4. This will be f of 2 raised to 8 into f of 5 raised to 4 plus f of 2 raised to 8 plus f of 5 raised to 4, right? We know all these values. F of 2 raised to 8 we have found as 255. And f of 5 raised to 4 we know is 15. So f of 2 raised to 8 is again 255 plus 15. Multiplying 255 and 15 and adding these two to the answer, we have the final value. 255 into 15 we can very easily find with the on-screen calculator. 255 into 15 shall be 3825. This entire thing is 3825 plus 255 plus 15 is very clearly 4095. And obviously it is your B option, right? So that is one way of answering this particular question, guys. Now let's look at a slightly convenient, a slightly better way of solving the question, guys. If I ask you what would be f of 4, you would approach this problem to be f of 2 into 2. By definition, this will be f of 2 into f of 2 plus f of 2 plus f of 2, which will be 1 into 1 plus 1 by the definition. So 1 plus 1 would give you 3. And observe that 3 is nothing but 2 square minus 1. Okay. What if I asked you find f of 6? F of 6 would also be f of 2 into 3. By the same logic, it will be f of 2 into f of 3 plus f of 2 plus f of 3. And the value would also be same, 1 into 1 plus 1, which is 3, or 2 raised to 2 minus 1. Now, what if I ask you f of 12? F of 12 would be f of 4 into 3, which will be f of 4 into f of 3 plus f of 4 plus f of 3. F of 4 we already have found as 3, right? So this is 3 into 1 plus 3 plus 1. This is 3 plus 3 plus 1, 7. And 7 is nothing but 2 raised to 3 minus 1, right? Okay. Now, here we can begin to see a pattern. When it's f of 4, we have two prime factors, 2 and 2, not distinct, identical prime factors, but we have two prime factors for this given number, right? So the value of f of 4 in this question is 2 raised to 2 prime factors minus 1. Similarly, when you found f of 12, 12 is basically 2 into 2 into 3. There are three prime factors, and that is why the value of this function f of 12 became 2 raised to 3 prime factors minus 1. And now I think you can see a pattern here. If a number is made up of n number of prime factors, the value of f of that number will simply be 2 raised to n minus 1. In this case, if you factorize 1,60,000, we have seen it is already 2 raised to 8 into 5 raised to 4. It is made up of 8 plus 4, 12 prime factors, right? So the value of f of 1,60,000 will be 2 raised to 12 minus 1. That's 4096 minus 1, 4095. Very frankly, I didn't solve the question by this logic, but I arrived at this logic by looking at the options. All these options are like 1 less than a power of 2. So that's what gave away. And yeah, that's another way of solving it. The answer is 4095.